research is on Madagascar's mangroves. And mangrove forests are among the most highly productive, ecologically important ecosystems in the world, and they're declining at a rate that's even faster than coral reefs and forests in general. And these vulnerable ecosystems are areas of high biodiversity, and they provide a number of vital sources for nursing and breeding grounds. They also protect the coastline from erosion during natural events like storm surges, hurricanes, and cyclones. And they sequester over 30 million metric tons of carbon each year, as well as provide food, fuel, and other natural resources for the local communities in Madagascar that use the mangrove areas. However, mangrove forests are declining, and they're experiencing some tremendous stress due to climate change and human environmental degradation to the environment. And the region of interest for our project is Madagascar, because Madagascar is a very remote region. It's very hard to access, and so it makes sense to use satellite remote sensing to identify trends and changes on this island. So we wanted to use, well, we'll go into the methods, but we are doing some change detection. We created some change detection maps of Madagascar as a whole island and country, and also through three different regions of Madagascar that are really interesting.
So this is one of the images that when we process we're going to find out the mangroves. So we changed the color band of it so that it's easier to identify the mangrove area and the tropical forest. So we download the Landsat images, the Landsat 4.5 and the Landsat 8 images from the GlobeFits, and then we integrate the remote sensing and the GIS skills for the analysis. So on N3, we use the ISO data classification to perform the supervised classification to indicate the mangrove areas. And then we convert the classification to the shapefiles. So on AppMap, we load all the shapefiles on AppMap, and then we merge all the shapefiles into one shapefile so that it will be easier for us to do the change detection. So for the change detection, we intersect the 1989 and 2015 shapefiles to do the change detection. So the 1989 will be the loss, and then the 2015 will be the gain. So this is our results. So in this map, we basically see that in some areas there are actually some gain, and in some areas there are some loss. But overall, we found that there are slightly growth in the mangrove forest in Madagascar, which is maybe because people are more aware of the importance of the mangrove, and then there are also some reforestation of the mangroves. So this is one of the regional maps that we make. So here we can see that on the top is the 1989, and then this one is the 2015. You can see that although there are some growth here, but in this large area there are all the loss of mangroves. So in this one, we can see that there are some. This is the 1929, and then this is the 2015, and then we can see that there are some gain here because this area, the red is darker, and then and it's also thicker too. Okay, so when we are doing this, we got a lot of problems and challenges because mapping the whole Madagascar is a relatively big area. So we download and process about 27 Landsat images, which is a lot, and then because of the bad quality of the Landsat 4.5 images, so even we change the color band, sometimes it's hard to distinguish which is the tropical forest and then which is the mangrove areas. That's why we may underestimate some of the mangrove areas in the 1989. therefore the insufficient time, and we don't really have the enough people to process all these things, so it might cause some error in our results.
Okay, and so just a little bit of analysis about the importance of mangroves. So despite the mounting challenges of climate change and also human influence in Madagascar, there is some positive actions that are being undertaken, and a lot of substantial positive action actually. So we have a lot of investments and reforestation practices are underway. Several areas of Madagascar's western coast has been reforested in the past decade, which could account for the regrowth and the gain that we see in our maps. There is a slight growth. It's only by 27.2 square miles, and so it doesn't seem very significant, but it is because it's saying that there is some gain in the mangrove area due to recent reforestation practices. For example, Eden Project's Worldwide Fund for Nature and Wildlife Conservation Society have played really big roles in reforestation of the western coast of Madagascar. And Eden Projects alone has been planting 1.4 million mangroves a month in the country, with approximately over 79 million mangroves reforested to date since 2007. So that's a lot of mangroves being planted every single day by one conservation organization. So their advocacy from these organizations has helped offset carbon emissions, because mangroves, again, they sequester over 20 million metric tons of carbon each year. And it has protected the unique biodiversity found in Madagascar. Madagascar has 2,000 species that are only are native to Madagascar, and so by protecting mangroves, we're protecting species that wouldn't otherwise exist. And it has shaped local mangrove management practices through education and community outreach. A lot of locals of the Malagasy people have been really involved in reforestation efforts and managing and monitoring the mangrove ecosystem. And this has ensured a more sustainable future for these mangroves in Madagascar. So in conclusion, while our assessment may have some inaccuracies, this study provides the most up-to-date spatial and temporal distribution of mangroves. The most recent, well-regarded research on this subject of Madagascar was by jury, and that was completed in 2005, which is almost 11 years ago. And 11 years, a lot has changed in Madagascar since then. So our study provides more up-to-date analysis with better, higher resolution data that can help impact and support future decision-making processes in Madagascar to protect and conserve the mangroves. And that's it. And if you want to check out our website, we have a lot more maps that we did not include in our presentation, and it's all up in our website. Thank you.